Good afternoon, everyone. Thank you for being here. It's a pleasure for us to have this opportunity to talk to this amazing assistant audience. So our hosts, as already told, are Carlos and José. They are going to talk about software architecture, and the idea is to give a vision on why this is important, okay? And what are the advantages of pursuing a good architecture. I hope you have a very good time. You interact with us. We are going to interact a lot with you. So I hope you enjoy this lecture. Thank you. Thank you.
Okay, thank you, Ricardo. So my name is José. I'm a developer at Jumia. And we are going to talk a little bit about software architecture and, as Ricardo said, why it is important. Does anyone here have some broad idea of why it might be important, the software architecture? No one? Okay. So, today we are going to talk about a couple of topics. So, the foundations of software architecture, how it was born, the main architectural patterns and how to use them, how to make software architect models easy to be reused, and how software architecture patterns drive efficiency and productivity. So across the presentation, we'll present a couple of patterns. There are many more, but we are more or less focused on what we've learned in Jumia. So it shows a little bit of our path. So I think it may be interesting. So let's talk about the software architecture foundations. Does anyone have any idea? Have you studied the subject? No one? you need to help me. Yeah. Okay, so back in the 60s, so when computers, when the software becomes more important, everything was very disorganized. People doing applications, there were small things for a single purpose, nothing very special. And suddenly and very quickly, there was a need to create bigger applications that encompass several domains and all that. And there was no system for developers to organize their application. So everything was a little bit confusing. And some people started to make a study on the field, and they started to realize that they could improve. And so they took some lessons from the industry, from the building architectures and all that, and they start to see how they could create systems that would facilitate the way we develop software and how we could benefit from that. So it starts with a mess, and slowly we are trying to bring order to the chaos. So basically, there are several definitions, but the main purpose, we can say that the software architecture is a set of structures that we use to reason about the system. What this means is, essentially, imagine like you have little blocks when you're doing house. You start putting them together, you design something. So if you imagine that in terms of software, we have little blocks, little components. We want to link them together. And so we need to decide how the components are going to communicate among them, what is the best way to achieve the best performance, and a couple of other things. So essentially, the software architecture, it's allow us to reason and also to communicate about the system. Because if we don't have an architecture and I want to explain something, how does it work? It's more complex. If we have a common language, then we can actually talk about the system and use some terms that everyone can understand, so everything becomes a little easier. And the goal of the architecture is always to support the system life cycle. This means that the systems become easier to understand, easier to develop, easier to maintain. And when we say maintain, we say change, improves, enhancements, and all those things. And also deploy, because in the end, especially if we are talking about web or something like that, we always need to deploy our application. And the final goal is to minimize the cost and maximize the productivity. Any questions? Come on. Este é meu? Okay, so let's see what is an architectural pattern. As I was saying before, we have building blocks. Imagine little components of software. And we want to lay a set of guidelines that will allow us to understand how those little pieces interact with each other. Okay? So it promotes reusability of software components. We'll see this more up front, how we can achieve that. It has an high focus on maintainability, because one of the most important things in software is that it's not something that you do once and it's done. You do it once and you keep on improving, because there are always new features that need to be added. There are bugs that we found, requirements change. So we always need to touch what we've done before. Okay, so that's why this is important. So this basically is this like, we need to evolve, and we need to do it as best as possible. We also need to have a way, so when we are designing something, we should always have an eye on security and performance. And when we design something, we are trying to reduce the limitations that the humans have. If something is too complex, we cannot reason about it. Or it becomes very difficult. So the idea is like something that is very common in computers, divide and conquer. So let's make this as small as possible, and let's see how we can make these little parts talk and work together. So this is like the most important thing that we try to achieve. Okay, so my colleague is going to speak now.
Hello. Okay, the next topic, we are going to talk about some patterns, the main architecture patterns, and how to use them. There are two types of scopes. The first one is the system architecture, where we are going to talk about the monolithics and the microservice. And the other one is the application architecture, where we are going to talk about two of the most common patterns that we can do to design a software architecture. In terms of the first scope for the monolithic architecture, I have one question for you. What do you understand by monolithic? Go ahead.
Something is single, it's gone a single direction, or it's go for a single direction, or something single. It's mono. That's all I sense about monolithic.
Can you repeat? Sorry.
I think it is mono. It is something single, or it's go as a single direction.
Yes. Thank you. Anyone have an idea? Okay, I think you can.
Not flexible. Not flexible.
Why do you think it's not flexible?
I believe that's the meaning of the word. Like it's hard to change.
Okay. Anyone?
I think it means it's a type of architecture that defies the whole point of having an architecture. So, for example, instead of having a good base, collecting different aspects of the software, you just have a single building block and you keep building on it, which defies the whole point of having system architecture.
Thank you.
I think monolithic architecture is like having the whole system in one code base, in one repository, having the same shared code.
Yes.
Not like microservices where it's each part separate.
Yes, that's true. We can have many components or modules in one single application. Okay, this is just an example, a diagram of the monolithic. As you can see, we can have several components or modules inside of the same system application. Then they are connected to only one database. Okay. Okay. In terms of the overview, as you said, all the business domain is in the same system. Okay. Monolithics are easier to start with. Imagine that you want to create a company and you need to go faster to the market, so you can create a monolithic to do a proof of concept to make sure, okay, this is what I want. So the best way to do that is to implement a monolithic. In terms of communication, because all the components and the models are in the same system, so we don't have any latence between the different domains. And of course, in terms of infrastructure, we don't have much effort, and also in terms of the application deployment, because we have only one application to deploy. So far, so good? Do you have any questions? Cool.
Can we have an example of the? Can we have an example of the last slide?
Yeah, in terms of the example, imagine here. I think every company has a monolithic. Jumia is no different. We have a monolithic, and we can. In terms of the example, is where imagine we have a lot of service inside of the same system. Okay, every time we have dividing several modules. Okay, payment module, order module, and so on. And imagine that I need to change something here. Okay, if I change something here, what I need to do to have my change in production. Do you know how to do that?
Deploy.
Yes, but to apply your change, you need to deploy this entire system, right? Even Amazon has, I think, during 20 years, they have a huge monolithic that they are trying to split in a different service, or to extract most of the logic to separate and to create different applications.
Thanks.
I don't know if it was clear or not. Thank you. In terms of the usage, we can use monolithics in high performance transaction applications, and I can give you one example. Stock exchange, for instance. I think in that case we should, or we can use a monolithic. Why we can use that on that critical application because as you will see later, we don't have latency when we have a monolithic, right? So when we are working with the stock exchange, every millisecond counts, can have a huge impact on the stock market. And also, as I said, for proof of concept. Imagine that you want to, okay, I'm thinking about this idea, I want to go to the market to see if the customer or the final customer wants or appreciate my product. So you can create a monolithic to do that, and you send to the market as a monolithic. And later, if everything went well, you can escalate to a different phase. In terms of drawbacks, as you said, as you can see, lack of deployment dependencies, as I show you on this diagram. If I change something here, to apply my change in production, I need to deploy this entire service. What is the disadvantage of that? Do you have any idea about it? Imagine that I change something here, and my change will break my application. So it means that when I will deploy my entire system, if my application doesn't start, I will have downtime, right? Okay. It's harder to parallelize the developments. Imagine that we have, I don't know, 20 people from here to work in the same application. What do you think that is going to happen? Do you have any idea? Do you know about GitHub and code review and so on? Okay, imagine to have 20 people, or not 20 people, imagine that you have 5 teams to work in the same system. Okay, imagine that you need to implement a feature, then you are waiting for other team, that the other team do the code review. Also, you are waiting for the contract, for all the codes that depends on, you are blocker, right? Even in the conflicts that you may have during when you want to merge your change to development branch, for instance. In terms of the, as I mentioned, this one, for instance, is when we change something and that change will break our system. And of course, when we have a monolithic, we are connected, linked to one technology. Imagine that my monolithic was done in Java. If I want to improve my product, I need to hire more people that knows Java. I cannot hire people that knows only .NET, Python, and so on. We are stuck on that technology that our monolithic was implemented. Do you have any doubts about what I said about the drawbacks?
Or any
Makes
questions?
sense? Okay. Right now we are going to talk about microservice, okay? And I'm going to show you this example. As you can see, here what I did comparing with my monolithic was I split my monolithic, the components, modules, in several different applications. It means that right now I have one application for the discount, and I have another one for the order, for instance. Okay? What is the advantage of separating all these models in different applications?
That you can deploy each separately. It doesn't depend on each other.
Yes, correct. Imagine that I need to do a change here, okay? and I want to deploy my change in production. What is the main difference between what we see here comparing with the monolithic?
If there is a bug or an error, something in the discount part or discount, it will not affect shopping cart or the catalog.
Exactly. We avoid the downtime. If I make a mess here and my application for any reason doesn't start, so the other service continuing running. So I don't need to worry about it. So we avoid to having the downtime. Okay, as I said, we have several applications that combine and make a system. The microservice service, in terms of communication, can be heterogeneous because we can have HTTP communication, we can have message broker and stuff like that. As you said, in terms of domain, nothing depends on, okay? So we can, each application has its own specific domain. And of course, one important thing is I don't want, I can have multiple services in a different language. Imagine that the first service that I do is in Java. The next one, I can hire more people that can do another service in Python or in PHP and so on. In terms of the usage, basically, if our system is a system that continues to evolving, so it's nice to have to apply that change. If ACID, do you know what it means? This sigle?
I'm pretty sure that someone knows. Yeah, it looks like she has already taught you that.
It's atomic
Consistency.
consistent isolation and durability. Even for me, it's not so easy because I'm used to use the Sigler, and when I need to translate for the meaning, it's not so easy.
So did you understand what this means? The communication between applications can be heterogeneous. Okay, can you go back? Okay, so we have all these applications, and they need to speak with each other, because when you have the monolith, you have classes you can extend, and everything is there. You have everything available. Here it's not the same. So we have an application, it has its own database, another one with its own database, another one with its own database. For some reason, so the user is buying something, there's something on the shopping cart, there's a code there, like product ID, but the shopping cart needs to speak with the catalog, okay? So it needs to know what's the name of the product and the price and all that. So how would you do this communication? Ideas? Yes, one. So we can use a message broker. Other ways? Nothing comes to mind?
What about HTTP?
So you can use the HTTP protocol. You can have some endpoint here. This application can request some information to the catalog. The catalog will reply back. The situation here at this will be synchronous. So you make a question. If you use HTTP, you need to wait for a reply. If you use a message broker, you can send a message. This one is listening, waiting for message. It will consume the message, do whatever it needs to. Actually, it's the other way around. This one will consume the message, do whatever it needs to do, sends another message, that the shopping cart is consuming, and this can be asynchronous. So if we are talking about systems where there is an heavy load, to be asynchronous can be an advantage. It can bring other type of problems that need to be solved, but so it's easier to scale when we use this kind of communications. HTTP is a little more difficult. So that's what that little thing wanted to say. Thank you.
Thank you, Jose. Okay, in terms of drawbacks, comparing with a monolithic, of course, here we have multiple applications to communicate with each other. Of course, we are going to have some latency and some overhead between the applications. That's why I've mentioned a good example too that you can apply the monolithic is where you are working for the critical projects where this communication latency it's very, very important. In terms of complexity for our infrastructure, you have to deploy more and more applications. So in terms of complexity, it will increase, and also in terms of the costs, also it will be much more. And as you can see on this diagram, okay, it's not a requirement, okay, but every microservice has its own database. So what it means having its own database? Imagine that in a discount, for the discount, we are going to persist data about the discount, and not only, we need maybe to persist data about the order, and the order needs to persist data about the discount. So one of the drawbacks is we are going to have data duplication, and of course, we are going to have some integrity overhead because of that. Does it make sense? Okay. Okay, in terms of the, okay.
Why not have one database instead of 4?
We can, but imagine the following example. If I have just one database, okay, and I have 5 microservices running, imagine that I want to add a new field to my database. What will happen?
It would be there will be many requests to one database.
Imagine here, if forget about this one, and we have only this database, and I add one field that it's responsible only to proceed to store on database something about the discount. What you need to do here is to deploy the rest, and you need to change the rest of the microservice, because you need to propagate your change, right? Because you are changing your database, you need to change your domain, okay? And also you need to change your entity that is shared between all these microservices. You can use one database, but I would suggest to separate because this is the concept of microservice, to have to be or to run independently, not depends on anything. In this case, once you follow the contract that you can establish for the microservice to communicate with each other, you don't need to worry about anything else.
Thank you.
Okay, in terms of the application architecture patterns, we are going to talk about the layer pattern. Do you have an idea what is the layer pattern? Yes, no, maybe. Okay, this is a good example of the layer pattern. It can be split in several layers. These we have just an example of 3 layers. We have the presentation layer, then where imagine the presentation layer could be our front end, could be our APIs. Basically, is our entry point of our system. Then imagine our front end, you need to submit data. Imagine that I want to persist or get some information about the user, for instance. Okay, then we have our business layer. The business layer here, we can basically validate business logic, business rules, and also to validate the business rules, to apply business of the requirements that we want to implement. Some logic should be done here, and then we have the data where we can persist our data on our database. Okay, in terms of the flow, as you can see, is the communication comes here, and to here. Okay, we can do that, but I wouldn't advise you to do that because we are jumping something that is important. If we do that, of course, we can also to send directly to here. But if we do that, what will happen is you are going to add logic, a business logic, for instance, here on the presentation layer, and our presentation layer should be like dummy. She doesn't know, or she doesn't need to know anything about our business logic and validations. Okay, but our presentation layer must just receive and pass the data to the business layer. Okay, do you have any questions about this? Okay, this layer is pretty much common. Most of the companies are used to implement this kind of architecture. Okay, as you can see, each layer has its own responsibility. Okay, the presentation layer, business layer. Layer is responsible to validate everything about the rules of your business. Okay, and in this case, the domain is not isolated. What it means, what I want to say with the domain is not isolated. Do you have an idea? Okay, it means that here, our domain can be here or here. Okay, what is the problem if our domain stay here or here? Okay. You don't have any boundary here, okay? It means that if you share your domain in a different layers, if you change something, you need, if you imagine that you need to change something here, you need to fix the problem here, okay? That's why the domain is not isolated. And we are going to see a subset of this architecture that will allow us to have a total domain isolated. In terms of usage, basically it's pretty much common. So you can apply this pattern to any application, okay? In terms of drawbacks is basically you have a coupling between your layers. It means that any change that you apply here, it's a point of failure of your application. And of course, here, do you know what is the dependency inversion principle? Is where you imagine here, okay, to achieve the inversion, the dependency inversion principle here, to do that here, you should point, your presentation layer should point to here. So our business logic should not know anything the way that we implement our persistence layer. Okay, what we need to do here is just to have an interface, a contract, and then your persistence layer knows you invert this arrow, so our persistence layer knows about the contract, and you just need to get the interface, instantiate the interface, and then you can implement whatever, or select whatever they want to implement our persistence layer. Okay, guys, when I mean the contract is not a contract, okay? It's like an interface, okay? And then you define, a contract for us is when you define an interface, and then you have a class that is going to implement that interface and needs to follow the methods that our interface provides. So you need to design and to implement the logic of that contract. Okay, it's clear for everyone?
Please, I have one question. How is this pattern different than the monolithic pattern?
The monolithic is the way that you provide a system in terms of infrastructure. Okay, you can have monolithics that implement this architecture. Okay, and even you can have microservices also that can implement this architecture. Basically, you need to think in terms of system. System is related with infrastructure, the way that I can deploy my application in production, for instance.
Okay, thank you.
So we are going to talk now about another architecture that we can use in the applications regarding to the question that you were making. So the monolith or the microservices in terms of infrastructure, here we are talking about the application itself. So does this rings a bell to anyone? No? Okay, that's good. Let's see if we can draw something here. So, oops. This is actually a very interesting architecture. It's becoming very, very popular. It's not recent. So, the idea on this is we have the business logic here. So this is an application. It has nothing to do with deployments or infrastructure or something, okay? So we create some sort of business logic. And here we have other components. This is like an API for the user interface, console API, test scripts that can also be used there. We have databases, message queues, HTTP protocols, and all that. And this has something here that says inputs, outputs. This also, the first name of this pattern was actually input, output. So now they call it hexagonal. By the way, if someone asks, there is no special reason for this name. It's just because the first time it was presented, they used an hexagon, so it became called, the name became the hexagonal pattern. So what's interesting here is that we can imagine this as being plugins. Okay, so imagine that these are plugins, and all of them, they don't know anything about each other. So the idea, I'll try to do it here. Imagine this is the business logic, like we have there. And basically what we are going to establish is a contract, an interface, okay, that will, let's say this is the user interface API. And we define a contract here that is going to receive something. So this is an interface, okay? And this is the only thing that exists here. So we are going to import this user interface, the API, is going to use this contract, okay? And the data will flow in this way. Now imagine that something comes in and we want to go to the database. So let's put database here. Okay, it's a different service. We define a contract here again. So an interface. Let's say it has only one method, which will be persist. Nothing else. Okay, and it's the only thing which is inside here. It's just the interface. And it will be implemented by this layer here. So this will work like this. And that's when we get the inversion of control. So the data flows in this way, and suddenly it doesn't go like that, like in the other one. So it actually is going to be like this. So the data goes in, we do whatever we need to do, and then we call some service, which is there, implementing this interface, and it stores the data. Another interesting thing is for this to work properly, and we have data structures here, and normally we replicate the same structure here, or very similar. It depends on the use case. And here we will have the same or a very similar data structure, which will be the entity. So what happens is our API receives an object, which will be this data structure. It will be converted to this one that we use in this domain. We do whatever we need to do here with it. We convert it again if we want to go there. If we have a result from the database, again, we are going to use a conversion, convert it to the business model, to the business layer object. If we need to do something, some transformation, we do. If we want to send it out, we again convert it to a data structure for the response. Is this weird for you? Do you think it's logic? What benefits do you think we get from all this mess? Yep. There's a Lily. Can you go there?
The benefit is that you are isolating all the parts of the architecture.
Precisely. And that leads to something very important, which is testing. Okay, so as all the components have their own data structures, we can test them in isolation. So we do tests for this, we do tests for this, we do tests for this, and sometimes you don't even need to raise all the system to make sure that everything works. We can do tests in a much better way. So the isolation is very, very important on this. We can now go here. If you have any doubts, please. Now imagine, just going here again. Okay, so we have a contract here. Okay, we have this area of the application here, which includes maybe repositories and some services to store data or whatever. And we are using MySQL. Okay, for some reason, MySQL starts to become slower. Suddenly, Oracle decides that we have to pay, whatever happens. And we need to change this, or we want to change this. Does it look difficult? Does it look easy? Because this will be the only place where we need to touch. As long as we keep the contract, if we follow the interface, so the contract here, we can change this, we can replace that database with a minor effort, which is much simpler than when we have everything interconnected. The same with message queues like Kafka or RabbitMQ or things like that. We can also use different ones. Questions? No one has questions? Okay. So we have three main layers, as we've seen there. We call it the driving adapter. So this is what drives. And this is the business logic, and this is the driven adapter. So they are output things. So everything is decoupled, inputs, outputs. So everything becomes simple to test, especially that. And it abstracts the business logic from all the other layers. So when the system is much more open to change, when you need to work on some small part of the system, as everything is separated, we get lots of advantage here because the change is always affect some small part of the system. If you have questions, just interrupt me, okay? So, oops. So when should we consider the hexagonal pattern? When we have applications that need lots of change very frequently, which is every day more common, depending on the business area, but is very common. So the drawbacks. We have that thing that I mentioned, the entities duplication. So we are creating lots of entities or objects. They will be very similar. Sometimes they are exactly the same between several layers. It's costlier and more time consumer to develop because you have more work to do. You have to maintain all those entities, you have to design and all that. And as a learning curve, which is tricky. It's not difficult, but it's tricky because, as obvious, we have this in a system, so this is all the same application. Obviously, that we can import this from this and all that, and you can break all this. And that's not the idea. So we need to make sure that people know that this area should not import something from there and all that. We use tools for it that actually, if we do any mistake, it will warn us that you should not be importing that, and it won't even compile, okay? And that is something that it helps a lot. Yes? Oops.
So maybe I can ask a question about example applications that do exist and use the hexagonal architecture, because it seems to be very flexible, so we would expect some applications to actually use it. So are there examples we can illustrate to the students?
So we actually use this in Jumia. We have, let's see if I can make it simple. We integrate with several payment providers. So what we do is, imagine that we have Visa, we have MasterCard. This too will be okay. And we have some sort of application. The customer comes here, he wants to pay something. We have a set of business rules, and then we decide if we go here or there. Forget about, let's make it something like mobile money as well. So, what we do here, this is a microservice, this is a microservice, this is a microservice. And this is like one main application. All these microservices, we design them like this because they do change a lot. Because I always think change, Visa decides they use a new API, suddenly 3DS2 is coming, so there are lots of things that change. And this allows us to be much faster to have everything ready and deployed and deliver as much faster than any other architecture. So we actually use this a lot. So, now from all this, we now arrive to an interesting part is how to make software architecture models easy to be reused. So, any ideas? Yes?
Writing clean code would make it very maintainable. Clean code.
Yes.
Clean code is very important.
Yes. We will talk about that as well.
And maybe everyone in the team should have an idea about writing a good documentation.
Also
would be very important for new members in the team. And I think that's it. I don't know.
Okay, so let's see what happens when we try to use architecture. The first thing that we, let's say a team of people or several teams, we start to use architecture, and what will happen is something that we can say we become consistent. Because everyone is using, we are doing several applications using the same type of architecture. Okay, so we decide, okay, this is for our use case, we have this 3, 4, 5, 6 applications, this is a very nice pattern. So we decide to use whatever pattern we decide. So we become consistent. When things start to be consistent, what will happen next is that you create a service with that kind of architecture, you create another service with the same architecture, another, and suddenly when we realize, you start to see patterns. This means that we'll start to see some areas of different applications, but as we are using the same architecture, we start to see some areas of the application that do exactly the same. They are very similar. So they are like screaming, take me out of here. So you can extract them, and depending on the use case, it can be extracted to a library, extracted to another microservice. It depends on what you do. Without architecture, if you decide, I'm going to do all the applications anyway, what will happen is every application will be different. You won't see any patterns because you do it in one way, the other person does it another different way, so you won't notice the patterns, and you won't be able to find or realize what can be extracted from there, okay? When we arrive to this point, and this is not immediate, so you start doing the several applications because you decide to use a certain type of architecture. You do one service, another service, and that's when you start to realize, okay, I've got things here that I can extract to another place. Okay, so this is basically what I was saying. So architecture promotes consistency. Consistency reveals patterns. Similar patterns drive extraction, and extracted components can be reused. Okay? So the components that you extract, they can be used for a base for several applications that we have across the company. Even if they have a distinct, let's imagine that little part here, that when we saw the microservices, we have something like the push or the catalog, we have the shopping cart, we had the discount, and I think it was purchase something. And we saw that we had something here, which was the message broker, right? So all these applications, they will speak with the message broker. So probably when you start doing this properly, you can create something that can be reused, okay? So you don't need to write it every time. Okay, so you can extract, can be a library on this case, imagine, and you start to reusing it here in all the applications. So it's always the same code. Yeah, like this. So, yeah. So I'm going to add something. I think it's on the next slide. Let me check. Yeah, and I will go back again. So when we extract things, we know that because we have been used it already, they are proved and they are tested. This means that when you create a new service, if you use that little part of software, we know that it works, okay? If for some reason we realize there's a bug or there's some sort of change in the requirements, you fix once and you solve the problem everywhere. If they were all different and you find, well, there is a new requirement change on the message, you need to go, if you have 10 services, you need to do 10 changes in each service. If you are reusing, you just fix once, you solve the problems everywhere. Okay? So this leads to reduced costs because we are faster, we can solve the problems much faster, which means efficiency. It's a reduced implementation effort, it's done. So you are creating a new service, you don't need to worry about the messaging part, it has already been done. And so as we don't have to do so much work, the points of failure is reduced. Okay? Questions? Because I've been talking for a long time now. Yep.
So an example for what you just said would probably be like the nav bar, for example, in an application.
Sorry, Zay?
An example for reusing architecture models would be, for example, in the front end as like the nav bar, where it's always present no matter which page you are in the application.
That's a part which I'm not listening very well. So in the front end, I hear that.
Yeah, like the nav bar, for example, the navigation bar.
Yes.
This is an example of reusing an architectural model, since it's always present no matter which page you're on in the application.
It can be you are using something. It's a little different from the use case that we are showing here, but it's reusing a component. So basically, it's the same. If you are reusing any sort of component and you have tested it, you know it works, you are saving time. Next time you need to use it, you just pick it, plug it in, and it's done. So it's always good to reuse. Okay. Another thing that is also interesting when we use these kind of things, and that we have actually also done for ourselves, is as our architecture, especially between these kind of services, is the same. We use hexagonal. It allowed us to create some kind of tool that it bootstraps the service, so we don't need to write so much boilerplate code. We know that we have an infrastructure layer, that's where we put the database, where we put the message queues and all that. We have a business layer, we have an entry point, which can be HTTP, so it will be controllers, for instance. Could be other thing, but in this normally it's controllers. So we can create tools that allow us to bootstrap. So instead of writing everything from scratch, you know that this is the architecture that we want for this sort of applications. So we create a tool that bootstraps all that. And in 10 minutes, we have the basic working. And then, depending on what we want to do, we do the implementation according to the use case. Okay, this is the most interesting question. So, who are the architecture stakeholders?
Say they're probably the developers that are going to work on the project themselves. They get to choose which stack, technology, and architecture they want to work with, which suits the needs of the customer most, because he doesn't have a clue what architecture means.
Okay. More ideas?
I think it's users. Could be.
They help us. Okay.
I think the question that we are asking is, in the company, imagine, in the technology company, who are the stakeholders for the architecture? Who is responsible to design? Who is responsible to implement the architecture?
I think the founders should.
Okay. And
I think anyone who contributes in the making of the idea of the business itself, of the software application that I'm doing, anyone who contributes in the idea, anyone who thinks of the business plan, the interfaces, the developers as well. So anyone who contributes in the making of the idea itself is a stakeholder.
Okay. Okay, so for us, this may change. Oops. Do you want to make a question? Oh, okay. So the stakeholders are who should decide what kind of architecture is going to be used, how we will use it. This may vary from company to company. In Jumia, it's very interesting because who decides it? It's basically the team. We know the use case, we know what we want to do, we sit all together, we decide, we arrive to a conclusion, and everyone contributes. So that gives some, what you do, it's like if it was your own thing. It belongs to everyone. So we don't have those like gurus that just sit there dictating orders or something like that, because at least I think we don't believe in that very much. So we have a team, and the team tries to be as autonomous as possible, and the software is all about teams. Okay? Thank you. Books. Do you like reading? No? Okay. What about videos on YouTube? You do, great. So we have a solution then. So this is something that someone has already mentioned, clean code. This is like the most important thing that you need to learn, okay? Clean code is, if you do any kind of architecture with bad code, it's gonna be a mess, okay? Well, architecture won't save you from that, okay? So clean code is very important. Clean architecture actually drives you to hexagonal architecture. If you start reading the book, if you follow it, you will realize that what he is talking about is hexagonal. And domain-driven design, this is like a Bible. It's also very interesting. So this has 3 books. Now, if you don't like to read, clean code and clean architecture are easy to find. You go to YouTube, you look for Uncle Bob, you start looking for videos of Uncle Bob, you'll find everything, and he is a very nice speaker. It will be amazing, and you will love it, I'm pretty sure.